Hello everyone, my name is Prachi and today I am here with the chapter Decimals. Now this chapter Decimals is basically for grade 6 CBSE, but whoever wants to learn basic concepts of decimals can go through this video. Yes, so let's start our chapter Decimals. So we have learned decimals like the numbers such as 1.2 for example, 1.65. okay, so the numbers which has this decimal point, this is called decimal point. So the numbers which are with this decimal points, they are called decimal numbers or decimals. Let's see now, there we need to learn these decimals with their place values at the first place. So we have learned the place values of natural numbers or whole numbers. So suppose if I give example like 5260.231. Yes, one more factor. While reading these decimals, after the decimal point, every digit, this is decimal point, so after the decimal point, that is right side of the decimal point, every digit should be said separately. Like you can see 5260 point, it is actually 231. But after the decimal point, we are not supposed to say the numbers like 231. Each digit should be called separately. It should be 0.231 and not 231. Every point, how many places decimal will have, you should call out those digits separately. Okay, so this was important point while reading the decimal numbers. Now place value, you have learned the place value of these numbers like the digits before decimal point, that is this 5260. So let me write once again. 0 is present at which place? It is at 1's place. 6 is present at 10's place. Then 2 is present at 100's place. And 5 is present at 1000's place. So these are the place values which we have learned for the digits which are before the decimal point. Now let's see the places of digits which are after the decimal point. Okay, so this is the place value chart. It will help us to understand the numbers. So let me write it again. These numbers 5260. As you can see, 0 is at 1's place. I'll write 0 here. 6 is at 10's place. I'll write 6 here. Then 2 is at 100's place. I'll write 2 here. And 5 is at 1000's place. Okay. So in place values, we have these three factors over here. Either in question they can ask you that particular digit is at which place. So when they ask you which place, these are the places names. Okay, these are the places names. So when they ask you at which place this digit is present, you need to say either 1's, 10's, 100, whichever place that digit is present. Then they may ask you place value. Now place value of these digits totally depend on which place they are present. For example, if 0 is present at 1's place. So in case of 0, let me tell you, if 0 is present at any place, its place value is always 0. Okay, so you don't need to worry about which place it is at, 10's place, 100's place. Every place, if the 0 is there, that means its place value is 0. Now let's see about the 6. 6 is present at 10's place, so its place value is 60. 2 is present at 100's place, so its place value is 200, and 5 is present at 1000's place, so its place value is 5000. Okay, now the similar way, now all the blue part is over, which was before the decimal point. Now let's see the digits which are after decimal point. Now digits at after decimal point, now what are their names? Okay, so like 2 is the first number which you can see after the decimal point. Its place is called 1. Either you can say 1/10 or 10th. Then we have 3 is present at 100, 1 upon 100 or 100th. And 1 is present at 1 upon 1000's place, or you can say thousands, which you can see mentioned over here. These are the names of their places. Okay, again let me tell you, these are the names of the places. Now let's write these numbers according to their places. So at 10th position we have 2, and then at 100th position we have 3, and at 1000th position we have 1. Okay, now according to their position, let me write their place value. So 2 is present at 10th position, so its place value is 2 upon 10. 3 is present at 100th position, that's why it is 3 upon 100. And as 1 is present at 1000th place, it is the place value is in 1 upon 1000. These are the place values. You can see all the place values before the decimal point are written in this format there, because they are whole numbers, and all the place values after the decimal point, they are either expressed in these fractions, or we can also convert them into decimals. Now let's see how to convert them into decimal. For example, 2 upon 10. Now 2 upon 10, what do you need to, like, you know that when we write digits in this way, that is in the fractional form, it actually means 2 is getting divided by 10, right? So obviously 10 is bigger than 2. That's why your quotient will start from the 0. So your answer, that much you know, that your answer is starting with 0, like point, 0 point. Now how many zeros are there at its denominator, that is when it is amount like 10, 100 or 1000. So you need to check the zeros. Number of zeros is 1. So after the decimal point, there should be just one place of decimal. Okay, so there should be only one digit after the decimal point. Why? Because in the denominator we have a 10 and it has only one zero. For example, let's take the another number, that is 3 upon 100. So 3 upon 100, how many zeros we have now in the denominator? We have 2 zeros. That means your decimal point, after the decimal point, there should be 2 places. So now 2 places means one is 3 for sure, because it is 3 is there in the numerator, and then remaining is 0. Okay, so when you have 2 zeros on the denominator, there should be 2 places after the decimal point. Again, let's see this 1 upon 1000, how it can be displayed as in the decimal form. So 1 upon 1000. Now how many zeros are there again? There are 3 zeros. So after the 0, there should be 3 decimal places. So it's like 1, 2, and third place is nothing but 1. Okay, so this is how we convert. We will be having separate topic how to convert fractions into decimal, but this is a small information about it, like how to convert them. Or we can write, as we started with this concept, that how to write these place values. So these place value of the digits which are after the decimal point can be written in the fractional form like this, or can be also written like in the decimal form like this. Okay, so this is what we have learned, the place values of decimals. Now on this basis, you can get some of the questions that we will see now. Yes, so on the basis of introduction of decimals and their place values, you may get small objective or MCQs where they may ask you write in the fractional form or write in the decimal form. So let's see how to write it in the decimal form. 5/10. Now how generally we write 5/10? We have seen that 10th is nothing but this place. Okay, 10th is this place. So that means, and it can be written, it's seen 1 by 10, isn't it? So it is not 1 by 10, it is 5 by 10 now. 5 by 10. Okay, now we have just seen in the previous part how to write it, write this form, that is fractional form, into a decimal form. So how many zeros we have here? We have 1 0. So after the decimal point, there should be just one place, and that's why it comes with a 5, as we have 5 here. So that's it. 5/10 can be written as 0.5. Now let's see the next one. Next is 49 and 6500. Now when you get this and in word format, so that means 49 is your whole number. Okay, that should be separate. So it is 49 and, so let me write plus sign for and, 6500th. Now you know 100th means upon 100, because we are talking about the places after decimal point now. So after decimal point we have 6500th. Now 6500 can be written as 65 upon 100, that is 65 upon 100. Now if you convert this 49 plus 65 upon 100, how many zeros we have? We have two zeros. So that means after the decimal point there should be two places. Now as two places are there and we already have the two digits, that is 65. So there cannot be any more zeros. So what you need to see is 100 has two zeros, so you have two decimal places. Here 10 was having only one zero, so you have only one decimal place. So that's what you need to check, and then once you are done with the decimal form, now you can add it like 49.65. So when they ask you question 49 and 6500 can be written as like this. You may get some of the questions like write but they will give you particular number, that is for example 56.01 for example, and they will ask you to write its place value in the place value chart. Now place value chart is what? Is the one which is this. Okay, this is called place value chart. But you don't need to write everything actually. You need to just write these names, okay, in your table. Make the table and write just these names, and like this number you can see there are two places after the decimal point, and here there are two places before the decimal point. So 6 is present at 1's place, 5 is present at 10's place, this 0 is present at 1/10th place or 10th place, and this one is present at 100th place. Okay, so these are the places. If you write only these places in your table, that is also fine. And once you write these names, after that you need to write the numbers. Like 6 is present at 1's place, so you can write here. Then 5 is present at 10's place, you can write below the 10's 5. And then 0 is present at the 10th place, there is a decimal point here. And then 1 is present at 100th place. That's it. This is how you can show the place value of any given number in the place value chart. Very simple. Some of the very simple example. Okay, now let's see the next topic. Yes, our next topic is expansion of decimals. So you may get questions like, for example, if you have 34.098, okay, and they may ask you to write the expanded form of this number or expansion of this decimals. Now how to do it? There are two ways of doing it. They may ask you to write its expansion in fractional form, or they may ask you to write it in the decimal form. So let's see both of them, how to write it. Fractional expansion, obviously name suggests that you need to write the fractions. So the digits which are present before the decimal point are here 34. So it is just like how normally we write their expanded form, that is 30 plus 4. Okay, that will be absolutely normal, as these are whole number. You don't need to write them in the fraction form. Plus, now we need to write the numbers which are the digits which are after the decimal, and after the decimal we have 0 here, as you can write is like 0 upon 10, but which is basically means nothing, that is 0, and you don't need to write 0. You can write 0 here, but there is no need of writing 0. Then 9 is present at 100th place, so its place value is 9 upon 100, plus 8 is present at 1000th place, so 8 upon 1000. Simple, done. This is the fractional expansion of any decimal. Very simple. You just need to write their place value. That is what we do in expansion. We add their all place values, and that's how we get the number. Now how to write the same number in decimal expansion? So instead of this this fractional form, we just need to write their decimals. Now how to do that? 30 plus 4 will be as it is because they are whole number. Now there will be a change. 0 will be a 0 itself, so you don't need to write 0. 9 upon 100. As we have seen how to write 9 upon 100 in the decimal form is, how many zeros we have? We have 2 zeros. That means after the decimal places there should be after the decimal point there should be 2 decimal places. So it makes it 0, 9. Okay. So 9 upon 100 can be written as 0.09. And how to write 8 upon 1000? 8 upon 1000 is nothing but how many zeros we have? We have 3 zeros, so 0 point, we have 3 places, out of which 2 will be zeros and 8. That's it. So this is its decimal form, 0.008. And done. Your expansion of decimal in the decimal form, basically decimal expansion. So this is how you can write the expansion form. Now let's see how to convert, okay, which we have seen in the previous part, but let's see. You will get questions like convert the decimals into fractions. For example, if I take 1.5. Now 1.5 is in the decimal form, you need to convert it into fraction form. So whole number you should write separately. As you can see, there is 1 before the decimal point, which is whole number. So whole number should be as it is plus. Now 5 is present at which place? 5 is present at 10th place, so 5 upon 10. Now it is nothing but simply addition of fraction. How do we add the fractions? By right now you can see they are not like fractions. One is not having the denominator 10, so we have to make them like fractions by LCM. Now LCM will be 1 and 10's LCM will be 10, right? So it would be 10 upon 10. 10 upon 10 is what? 1, which is here. Okay, 10 upon 10 plus 5 upon 10. Now why did we take 10? Because 10 was our LCM. That's why we made it 10 upon 10, so that we can add the numbers. Now they have become like fractions. Once you get like fractions, it's very easy. Just add their numerators and you are done. So 10 plus 5 is 15 upon 10. That's it. This is its fractional form. So this is how you can convert the decimal form given into fractional form. Now opposite, let's see if suppose fraction is given. For example, 83 upon 100 is given and they ask you to convert it into decimals. Okay, so to convert it into decimals, you know how to do it. Like how many zeros we have? We have 2 zeros. That means, and anyways you are dividing 83 by 100, so obviously your answer will be 0 point something. Now what is that point something? As you can see, there are 2 zeros in 100, so there will be 2 decimal places and we already have 2 digits here, that is 83. That's it, done. So this is how you can convert fractional form into decimal form. Now they may also give you expanded form of any number, like they can ask you 60 plus 3 by 10 plus 4 by 100 and they will ask you to write it into decimal form. So as you can see, 60 is without any fraction, right? Without any denominator. So that means it is our whole number. So it will be as it is 60 point. Okay. Now 3 by 10, that means 3 is present at the 10th position and 4 by 100, that means 4 is present at 100th position. So your decimal number would be 60.34. And that's how these are some of the small questions you may get in your exam to convert decimals into fraction, to convert fractions into decimals, and to convert expanded form into decimals. Very simple small examples I have given. Now let's see the next topic. Our next topic is decimals on number line. Now in exam you may get questions like they will give you some fractions, some decimals like 0.5 for example. So they may ask you to show it on the number line. So 0.5, first you need to find out that the number is in between which two whole numbers. So you can see it is 0 point something, that means it is greater than 0 but it is lesser than the next number, that is 1. So that means 0.5 lies between 0 and 1. So you can draw a number line, divide it into 10 parts. And that number line should be between 0 to 1 as a number lies between these two numbers. Okay, so divide the number line into 10 parts and then every part is like just next line after the 0 is 0.1, then we have 0.2, 0.3, 0.4, 0.5. This is what we need to show, right? So this is how you can show it, your 0.5 number on the number line. You don't need to write the other numbers as I have written, but I just wanted you to show these numbers. So even if you get questions like show 0.1 or 0.3, this is how you can show. Now for example, if I take another decimal, that is, let's take some other decimal like 2.7, for example, 2.7. Now can you tell me 2.7 lies between which two whole numbers? So right, it has crossed 2 and it is going towards 3. So 2.7 lies between 2 and 3. So your number line should be between 2 and 3. Again divided into 10 parts, and now every number, like you can see, this would be 2.1, 2.2, 2.3, 2.4, 2.5, 2.6 and 2.7. So here without showing any other numbers also, if you show just 2.7, because that is what your question is asking, and this is how you need to show it. Circle it and show it that this is the point which is 2.7. Very simple concept of showing decimals on the number line. Now let's see the next topic. Our next topic is like and unlike decimals. So just like we have like and unlike fractions, we have like and unlike decimals. Very simple concept. So all the decimals whose decimal places, number of decimal places are same. Like for example, 0.5, 0.7, 1.5, 1.9, 2.6. You can see every decimal here has only one decimal place. Okay, so those who have same decimal places, we can also take example like 0.25 or 0.39 or 26.35. Then we can also take 345.65. You can see, even though I have used whole numbers differently, like here 00, here 26, here 3 digit 345, but there are decimal places, number of decimal places, here 2, here 2, here 2, here 2. Okay, so you can see the decimals now whose decimal places are same are called as like decimals. So all these are, these separately and these separately are like decimals. Like decimals. Now it obviously means the ones which are suppose mixed, 0.5, then we have 9.27, then we have 3.456. You can see here decimal place is 1, here 2, here 3. So they are now unlike decimals. Okay, so clear? So decimals who are having same number of decimal places are called like decimals, and the decimals which are having different, which is not same decimal places, they are unlike decimals. Very simple. Now in exam you may get a question like convert unlike decimals into like decimals. For example, if I have 7, 5.3, then 9.21, we have 8.406. You can see here they are unlike decimals as they have different decimal places. Here there is no decimal point itself. Here it is one decimal place, here 2 and here 3. So they are unlike decimals. Now how to convert them into like decimals? So we have to convert them in such a manner that they have the same decimal places. Now what you need to do is you need to choose the decimal number who has maximum decimal places, that is this here. It has 3 decimal places, so choose the one which has maximum. So here 3. Now every decimal number you need to convert it into 3 decimal places. So now 7 doesn't have any decimal point or decimal places. But if I make 3 zeros over it, Okay, so it also have 3 decimal places, which will make it as a like decimal with this our highest decimal places number, as it has 3 decimal places, but its value remains same. 7.000 means 7 itself. Then 5.3 has only one decimal place, and we need to convert it into or we need to add 2 more. So we can do this. So when we place 0 like on the right hand side of the decimal place, so it does not change the value of that number. So even though I wrote here 5.300, it still means 5.3. So when you place 0 on the right hand side in decimal places, it does not change its value. So you can place as many as you need, as many as is your requirement. Next number is 9.21. Here there are 2 places. We need 3. So let's place 1 0, and then we have 8.406, which already has 3 places. Now we have made all these decimals as like decimals. Like decimals. Clear now how to convert unlike decimals into like decimals. Now these primary or introductory topics we have covered in a part 1 of the chapter decimals. For next topics in the same chapter, please see my next part, that is decimals part 2. So until then, see you. Bye bye.